Hello everyone, welcome to my channel, UFAS Law of Universe. I am Amazir. Today we are going to see the fundamental principle of our universe, one of the law of Johannes Kepler, Kepler's first law. Have you ever wondered how and what are the shapes of the planets that are orbiting our sun or any other stars? The Kepler's first law holds the answer. Let's dig in. Before we dive into the Kepler's law, let's find out who is the brainful genius behind it. Johannes Kepler. Johannes Kepler is a 17th century astronomer interested in astronomy and astrophysics, and he found three laws to find about the planetary motion. They are called Kepler's three laws of planetary motion. In this video, we are going to find about the first law of him. So we are going to dive into his first law. So first, look at the picture of him in this side. Let's first dive into the heart of Kepler's planetary motion law, Kepler's first law. So what is Kepler's first law? Kepler's he observed many places and many times and stars and moons and finally found about the orbiting path of them. With some mathematics, we will see that later in this video. So first he found out the Kepler's first law just by visiting places and by stargazing. And you can also, that's the study of science. There are many websites to study about science, and you must want to be updated in this field also. Meet our sponsor, UFAS. UFAS is my blogging website about astronomy. I will post an astronomy news per day in that website, and the link is in the description. Please go visit them. It's very knowledgeable to you. I'm going to break down the law. The law is the Kepler's first law states the orbit of the planet is an ellipse. Ellipse means you can see it there. Ellipse with the sun at one of its poles. Foci, FOCI. Text here. FOCI is one of the focus of planet. Sun is one of the focus in another point is another focus of the planet, and they are moving in an ellipse orbit. We will see about the whiteboard drawing now. Let's break this down. An ellipse is like a stretched out circle, unlike a perfect circle which has a single center point. An ellipse has two focal points, known as foci. We have already told about foci earlier. Here's an example in the whiteboard now. This means that as a planet orbits the sun, it follows an elliptical path, not a circular one. Those times, they believe the sun and other objects are following the circular path. So that's the important breakthrough at that time to find the planets are orbiting in an ellipse orbit. And the distance between the planet and the sun changes as the planet moves along its orbit. These are the ones that Kepler's first law first invented or discovered. Let's dive a bit into the mathematics of this ellipse. The standard equation of ellipse is x squared divided by a squared is equal plus y squared divided by b squared equals to 1. Seems confusing, right? So I will put one of the slides to explain about this letter single by single. So let's move to the slideshow now. Here, A represents the semi-major axis, which is half the longest diameter of an ellipse, and B represents the semi-minor axis, which is half the shortest diameter. The two axes intersect at center of the ellipse. The key point is that the sum of the distances from one point on a ellipse to the two foci is constant. This unique property is what gives the ellipse its shape. Okay, now let's see how this applies to the planets in our solar system. Go to the animation. Here's the Earth's orbit. Notice how it looks almost circular. That's because Earth's orbit has a low very eccentricity, meaning it's very close to being a perfect circle. In contrast, here's Mars orbit. It's more elliptical than Earth's, meaning Mars' distance from the Sun varies more significantly over the course of its orbit. But why do planets follow elliptical orbits instead of circular ones? The answer lies on gravity and initial conditions of the planetary system. We will see about the general relativity in later videos, and we will see about the gravity, how it's worked and how planets orbit. That lies on this thing to be on. Let's quickly recap what we have learned today. Kepler's first law states that the orbit of the planet is an ellipse with the sun at one of its two foci. We have explored the shape and properties of ellipses, looked at the mathematical foundation, and seen real-world examples in our solar system. Okay, why it matters? What is the problem of it? Understanding Kepler's first law is crucial because it revolutionized our view in the universe. It laid the groundwork for Newton's theory and other theories that come around. Okay, if you enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe to UFAS Law of Universe for more fascinating insights into the workings of the universe. Don't forget to hit the bell icon to get notified about the latest video. For watching. I am Amazir, and this has been an exploration of Kepler's first law. Keep looking up. Thank you.